Okay, everybody, welcome once again to this channel. It's our new edition, it's our new session under sequence and series. Quite an exciting question, a bit of a trick question that we're going to explore in this session. And thank you very much for joining us once again. If you're new to this channel, just ensure that you have subscribed and turn on the notification bell so that you can be notified every time that we upload a new session. Okay, without wasting any time, let's get straight onto it. All right, let's look at this question. It says, determine the possible values of A and R if you are given that the sum where n start from 1, AR exponent n minus 1 to infinity is equals to 5. Okay, so they want you to get the possible values of A and R. I know that obviously the first thing that most of us would do is to know that, okay, this is sum to infinity because we can see the infinite symbol on top of that sigma notation. Then we know, okay, the formula for sum to infinity, our sum to infinity is being equated to 5. And we do know the formula for sum to infinity is A over 1 minus R is equals to what? Is equals to 5. Then maybe someone is stuck from that point to say, oh, how do I now find the possible values of A and R? Okay, it's quite a bit of a tricky question, really, but it's just easy to solve it with a remembrance of one of the most important restrictions that is not maybe anchored during lessons, right? So now we have to remember that in order to get the sum to infinity, it's quite impossible that we can get the sum to infinity. I mean, even me, the first time I heard it, sum to infinity, is it possible that we can add our terms in our series to infinity and we even get an answer? And it's quite surprising, right? Yeah, but now it's very possible, right, to get the sum to infinity, only given that your series, and this is very, very important, given that your series is converging, right, is a convergent series, right? You did discuss your convergent in your class, I'm sure, about convergent series and divergent series, right? If your series is converging, that is, your terms in your series are becoming smaller and smaller and smaller as we move to the next term like that, we can actually find the sum to infinity, because you realize that as they are converging, they are actually approaching 0, right? Then you find that maybe the largest term is very, very small, such that it can be negligible. Then we can even get the sum to infinity in that case, because even if we add that smallest term that is closer and closer to 0, it won't have any impact on our answer. Okay, so that's how it is possible to get the sum to infinity in a convergent series where your terms are getting actually smaller and smaller and smaller over time. For example, if you have a series like 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32, like that, you can see as we move over time, this series is becoming smaller and smaller and smaller, and we call this a convergent series. Hence, only on a convergent series we'll be able to get the sum to what? To infinity. Because if it's diverging like a series like 2, let's say a sequence like 2, 4, 8, 16, 32. Can you see this one is actually increasing over time? We call it diverging, right? Divergent. So the series here is diverging, hence we can't get the sum to what? To infinity, because I mean the largest possible value will be in trillions, billions. How can you add all infinite terms like that, whereas your terms are actually increasing to infinity? You see, it's quite impossible in that case. So this is what will help us to solve this question: the remembrance that sum to infinity can only be possible if our series is convergent, that is, our terms are getting smaller and smaller. But the most important thing, how is a series convergent? It is when your R is between -1 and what? And 1. So this gives you the answer of the first part of this question of determine the possible values of what? Of R. We have actually find the possible values of R there by saying R must be between -1 and 1. That is the restriction for convergent series that ensures that a series becomes convergent. Okay, so in this case, you get a mark for writing that. Remembering that sum to infinity only possible when a series is convergent, that is when R is between -1 and 1. So those are the possible values of R. Any R that is between -1 and 1 will ensure that the sequence becomes convergent, and in this case it becomes the answer here. Okay, now we are only left with getting the possible values of what? Of A. We are given that the sum to infinity equals to 5. Now we can use this statement and maybe express R in terms of A, come back to this restriction, replace, and then solve for A. Okay, so how do we do? We're going to cross multiply. We have A is equals to 5 into 1 minus R. We want to solve for R in terms of A, so we're going to divide both sides by 5. Then we have A over 5 is equals to 1 minus R. Then to solve for R, I can take R and transport it this side and transpose A over 5 this side, right? Then I will have my R is equals to 1 minus A over 5. Okay, so I've now solved for R in terms of A. What can we do now to find the possible values of A? We can come now where there is R, we replace by our R here, which is what? 1 minus A over 5. So we have -1 less than 1 minus A over 5, because we do know that that R is equals to 1 minus A over 5 as per this equation. Okay, less than 1. Now we can go and solve for A. Can you see? How can we solve for A? We can take out this 1. How can we remove that 1? By subtracting 1 both sides, right? Adding the additive inverse. So I'm saying -1, I subtract 1 here. I come here, I subtract 1. I come here, I subtract what? I subtract what? What we do on one side of the equation must be done throughout, right? On other side of the equation, so that our equation remains mathematically balanced. So -1 minus 1, -2, 1 minus 1, 0. This cancel. I'm left with minus A over 5 less than what? Less than 0. Okay. Now I need to find the possible values of A. I need A only there, right? I can multiply with the reciprocal of -1 over 5, which is -5. So I say -2 times -5. Remember, very, very important, when we multiply with negative or when we divide with negative, the inequality sign changes direction. Okay, now we are multiplying with negative. It means this inequality sign will no longer face there. It will change direction and face the other way. So minus A over 5 times -5. Even this one, we are multiplying with negative. It will change direction and face there. We have 0 times -5. Okay, so now finally we'll have, maybe let me change the color and maybe use yellow. We'll have minus 2 times -5. This is 10. Yellow is not visible. Let me use red. Okay, or white. White, it's fine. Here we'll have 10, right? We'll have 10 greater than 5, and 5 will cancel. Minus and minus will cancel. We are left with A, right? Greater than what? 0 times -5 is what? Is 0. Maybe let me write the final answer on top. That our A, if we write it properly, greater than 0, I can put it this side, greater than 0 and less than 10. Can you see? Less than 10. I didn't change anything. I just swapped the values and put the other one there according to the smallest value and the biggest value. Okay, so you can see that our A must be between 0 and 10, right? And R must be between -1 and what? And 1 for our series to converge. So these are the possible values of A and R. A is any value between 0 and 10. R is any value between -1 and 1. So that's how you answer this question. Bit of a trick, but I hope you find it very helpful. Thank you.